Hello everyone. In this video we are learning about the Doppler effect. And Doppler effect has many applications in our daily life. For example, it is used to show your speed when you are moving on the road. You must have seen those digital displays which show you your current speed or the speed of car. It's used there. And Doppler effect is used in radars to find the speed of the flying objects, and Doppler effect is used in sonars, in submarines, in ships. So Doppler effect has many applications. In this video we are learning about the Doppler effect. Doppler effect is phenomena related to change in frequency of sound due to relative motion between the source, the one which is emitting the sound, and the observer who is listening the sound. So in this situation, the observed frequency of sound by the observer changes. The original frequency of sound remains same. There is no change in frequency of original sound. But as it reaches to the observer perceives a changed frequency. This phenomena is called as Doppler effect. So Doppler effect is phenomena related to change in observed frequency of sound or any wave. So there are four conditions which we are going to explore, and first condition is observer is moving, and imagine the observer is moving towards the stationary source. So source is stationary. Let's draw a simple diagram here, and I will draw the position of source somewhere here and the position of observer somewhere here. This O represents observer, S represents source. The source is emitting waves which are reaching towards the observer. Let's say the frequency of wave is F. Now as observer moves towards the source with velocity v0, what will happen? The observed frequency will change. So to calculate the observed frequency, we can use a formula, that is F dash is equal to F, this F is original frequency, V plus V0 divided by V. Here V is speed of sound in air, V0 is speed of observer, and again this V is speed of sound in air. You may be thinking why I am using plus sign. So if you will see this motion of the observer, then observer is going towards the source. As the observer is going towards the source, observer will receive more number of waves, so frequency increased. When frequency increased, then to get the higher frequency, if denominator here is smaller than this numerator, then only we will get F dash larger than the F. So I am using plus sign. Now in next condition, when, and this is condition 2, when observer is moving away from stationary source. So in this case, we will use same formula or I should say similar formula, f dash is equal to f v, and I'm writing v naught, later on we will add sign here, and v. So when I said same, I changed it to similar because it's not same, it's a similar. So here we had used plus sign because frequency was increasing, and in this case frequency will decrease. So which sign should we use here? If frequency is decreasing, then we should use negative sign so that the numerator is smaller than the denominator. Now in third case, the source is moving away from stationary observer. So in this case, we will write the formula f dash is equal to f v divided by v plus vs. So now this formula in the third condition is little different than these two formulae. Here vs in denominator, earlier v naught was in numerator. So when the source is moving away from the stationary observer, the observed frequency decreases. This is what observer will perceive. Now in fourth condition, source is coming towards the stationary observer, and now you may have guessed, when the source is coming towards the stationary observer, the observed frequency should increase because the observer will receive more number of waves per second. So here f dash is equal to f v minus vs. Now I'm using minus sign because if denominator is smaller than the numerator, then only we will get the higher value of frequency. So these are the four formulae which will help us to calculate the observed frequency of sound when there is relative motion between the source and the observer. Now this may be looking a little bit complicated. Let me combine all these formulae in one simple formula, and we can write the compact formula f dash is equal to f v plus minus v naught divided by v plus minus vs. Now this may be looking even more complicated because earlier ones were simple, but no, it's quite easy once you understand. So imagine if we remember this formula of Doppler effect for calculating the change in observed frequency, we can make some changes here. That is, when observer is at rest, take v naught is equal to 0, and when source is at rest, take vs is equal to 0. Right? Now second thing, you may face some challenge with this plus and minus sign, when to use plus, when to use minus. So let me make that also very simple. If you remember only this formula, you can change plus and minus sign by using this diagram. So when you are in your exam, or when you are writing a test, or when you are practicing, draw a diagram exactly like this. You may ignore these number of waves which are moving, but you have to draw the position of source somewhere here, and the position of observer must be towards the left of this source. So observer here and the source here. Now use the coordinate system sign. So when you go towards the right side of the origin, you use plus sign. So when the source is moving away, take positive sign. And now when you go towards the left side of origin, you take negative sign. So imagine you are not going here towards the left of origin, but as you go towards the left of the current position of source, take negative sign. And when you are going towards the right side of the current position of observer, take positive sign. And when you are going towards the left side of the current position of source, use negative sign. And by using this method and this formula, you can calculate change in frequency for all the condition. If you like the video, hit like button and subscribe the video and share with your friends. See you in next video.